Hey, it's Mr. Lum again, and we're going to continue on with some of our Chemistry 11 stuff, and this time we're going to be taking a look at how to figure out the molecular formula. Last time we took a look at how to find the empirical formula, and we're going to continue on, and now we're going to look at the molecular formula. Just to recall from last time, the empirical formula is the most basic formula. Essentially, the empirical formula is the ratio of the elements that are part of the molecular formula. So here is our empirical formula here. All that this empirical formula tells us is that there are one carbon for every two hydrogens. So it could be CH2, it could be C2H4, it could be C3H6. Those are all following this 1:2 ratio. Okay, but we're going to figure out what it is. So I have two steps here. The first one, it says find the multiply number by dividing the molecular molar mass by the empirical molar mass. So we're going to write that down, and we're going to go find the multiply number. So I'm going to write multiply number. And that's going to be taking the molecular molar mass, molecular formula, molar mass, and we're going to divide by the empirical formula, molar mass. So we're going to take the molecular formula, molar mass. So let's read the question. It says, what is the molecular formula of a substance with a molar mass of 56? So this question gives us the molecular formula, molar mass. So it says that the molecular formula molar mass is 56.0 grams per mole. Now we need to find out what is the empirical formula molar mass. So the empirical formula is CH2. C is going to be 12.0. H is 1.0, but there's two of them. So when we add that up, 12 plus 1 is 14. Oops. Now when you do this calculation, you should make sure that you should get a whole number. Okay, so our multiply number is 4. Now it could come out to like 3.99 or 3.98, but it should like be very, very close to a whole number. What you should not get is something like a 3.5, a 3.75, a 3.33, or with a 6.6 or something like that at the end. It should be a whole number or just a few points away from being a whole number. So this one turns out to be a perfectly whole number right there of 4. So that's good. And then all we have to do is take our empirical formula, which is CH2, and we just like multiply each of the elements by 4. So we said there's C, there's only 1 right there, so we need to write it with 4, so C4. And then H has 2, so 2 times 4 is 8, H8. So our molecular formula is C4H8. Okay, so I took that multiply number and I timesed it by what was previously there, which is there's nothing, but that means there's a 1. And what is previously right here, there is 2 there, so 2 times 4 is 8. And that's how we get our C4H8. Okay, let's take a look at one that's a little bit harder, where we actually have to find the empirical formula first. So if you remember from empirical formula, we just take our elements, take the percentages, 39.0 and 61.0, turn it into grams, and then turn that into moles. And silicon is 28.1. Oops. Do some math on it. 39 divided by 28.1 equals 1.3879, or 1.388 I meant, and that's moles. 61 divided by 16, and I get 3.8125 moles. Divide by the smallest number. That's just 1. Divide by 1.388, and this is 2.75. I got actually 2.7468, but we're going to round that to 2.75, like that. Okay. And so 0.75 is roughly like 3/4, like a 3/4. So that's roughly a 3/4. So what that means is that I need to multiply it by a 4 to get a whole number. Okay, so I'm going to multiply everything here by 4. And so what that means is that I get SI is going to be 4. Okay, and then oxygen is going to be 11. Guess I should write some stuff over here. 4 and then 11. Okay, so our formula is going to be SI 4 and then O11. Okay, so we have found the empirical formula. Now we need to find the multiplying number. So the multiplying number is going to be our molar mass, and it gives us the molar mass of 576.8 grams per mole. And now we need to find the molar mass of our empirical formula, which is Si4O11. So 16 times 11 is 176. .1 times 4, that's 112.4. Okay, when we add these numbers up together, we get our empirical molar mass. So I'm going to do that, plus 176 equals, and I get 288.4. And I do perfectly get the number 2 here. Again, it could come out to like 1.99 or something like that. The numbers just worked out perfectly for me. So it came out to 2. That means I need to multiply all of these values by 2. Okay, here's a little pro tip. If this didn't come out to a whole number, you did something wrong, and you should probably start over again. But this did come out to a perfectly whole number, so I am confident I did it right. And so SI is going to be, well, 4 times 2 is 8, and O is 11, oxygen is 11, times 2 is 22. Okay, and that is my now molecular formula. So here's another one. This one is a little bit trickier because it doesn't give me the molar mass of the molecular formula, but it does give me the density of this thing at STP. So we're going to talk about that a little bit later. It's a future problem. So, but for right now, we're going to find the empirical formula. So we just have carbon and hydrogen right here. So I'm just going to write some stuff down. So carbon, hydrogen, 80% carbon means 80 grams. Hydrogen is 20, means 20 grams, times, change that into moles. Uh, 80 divided by 12 is 6.667. 6.667 divided by 6.667 equals 1. 20 divided by 6.667 equals 20 divided by 6.667 equals 2.999, okay, which is approximately 3. Okay, so we don't need to multiply any numbers here because we have whole numbers right here. Okay, so the reason before why we had to multiply when we had like a 2.75 is because we needed to multiply to get whole numbers. We have whole numbers. 2.9999 is essentially 3. So our empirical formula is going to be C1H3, and that's our empirical formula. Okay. Now, what we need to do is we need to find that multiply number. And we can find the empirical molar mass. That's pretty easy. So I'm going to write empirical molar mass, and that's going to equal, well, carbon is 12, and then hydrogen is 1. So 3 hydrogens, so that's 3 plus 12 is 15. 15.0 grams. Okay. Now, it says that we have a density of 2.6786 grams per liter at STP. One of the big things that you should be looking at is like this STP. It is a gas, and it since it's at STP, we can use that 22.4 liters per mole kind of number. The question probably should have said, and I probably should have wrote this, is like the density of this gas at STP is this, but anyways. So we're going to calculate, take that number and change it into molar mass. So we're going to start with 2.678 grams for 1 liter. Now, what I want to convert into is I want to convert into grams per mole, because grams per mole is molar mass. So I want grams per mole. So I need liters to go away. So I'm going to put 22.4 liters up there and 1 mole right here. And if you can see here, I'm going to choose a different color, green. Liters will cancel out, and the only units that are left are going to be grams over moles. And that's what I want. So I'm going to go 2.6786 times 22.4, and I get 60.00064, close enough to 60.0 grams per mole. Now, this right here is my molecular molar mass. So I'm now going to take my molecular molar mass, which is 60, and I'm going to divide it by my empirical molar mass, which is 15. And what I get is, 4. This is my multiply number. It took me a little bit longer to get it, but we did get it. Okay. So now that I have my multiply number, I'm going to multiply it by my empirical formula. So 4 times 1 is going to be C4. 4 times 3 is going to be H12. Okay, and so that's how we do this one.